Hi folks, this is section 4.2 number 55, working with mean value theorem. It's a tricky one, so we should really go through this together. And the key for this one is remembering the change of base formula for logarithms. And we've really not talked about this much at all, so it's a good time to bring that up again too. So the change of base formula is what we're going to use. It was really briefly in our notes, but we didn't expand on it very much at all. Change of base formula. And basically, it's if you have log base anything, let's call it A, of anything B, you can change it to have a log of a different base. And the bases that we like to use, the only base that we like to use is E. And that means we'll be working with natural log. So what it turns into is you get a natural log over a natural log, and we can work with natural logs. Whatever this is, whatever number this is here, whatever it's a log of, that becomes what you have the natural log of in the numerator. And whatever this base is here, where C is, that's what you have the natural log of in the denominator. So an example, if we had log base 2 of 4, we could rewrite this to make it workable as a natural log, because we even have a button for natural log on our calculator, of 4 over natural log of 2, and that would be much easier to work with. So we'll be doing the same thing here when we work with our mean value theorem. So I'm just going to put this in a box. We're going to be using that information, but it's not really part of the calculations for the mean value theorem. So our mean value theorem is f prime of C equals f of B minus f of A over B minus A. And when they're talking about A and B, it's going to be the interval endpoints. So we have our interval is from 1 to 2, so A is 1, B is 2. That's every time they say A and B for these, that's what they mean. So we'll work both sides of this formula. And I think I'll maybe do the right side of the formula. I'm going to do the left side separately, the right side separately, and then we're going to have to set them equal to each other. So let me just work on this side of the formula first. And so we need f of B and f of A. F of B is equal to the function evaluated at 2. And our f of x, our function that we're working with, is x log base 2 of x, but we're going to use a change of base formula to be able to compute better. So we'll rewrite it using the change of base formula. And so it's still f of x, but it's going to be then x times natural log x over natural log 2. So now when we find f of 2, it's going to be 2 times natural log 2 over natural log 2, and beautiful things are happening here that we have natural log 2 in the numerator and denominator. So this turns out to be 2. So in the formula, we'll be putting 2 right there. And now for f of A. F of A is the function evaluated at our left endpoint of our interval, which is 1. So we will plug right back into here again, 1. F of 1 is equal to 1 in place of x times natural log of 1 in place of x over natural log of 2. But just so you know, in case you don't already, natural log 1 has a value of 0. So that makes a fraction become 0, so the whole thing becomes 0. And therefore, our f of 1 is equal to 0. And that's going to go right here in the formula. So now we have f of B is 2 minus f of A, that's 0, over our B and our A. Remember, that's way up here. That's the interval from 1 to 2, so we'll have 2 minus 1. And that's 2 over 1, which is 2. So when we get to putting this whole formula together, all of this is worth 2. Next, we need to work on the other side of the formula, and that's the derivative. So once again, I'm going to use my f of x the way I rewrote it over here because that'll be easier to work with. So my f of x is equal to x times natural log of x over natural log of 2. And I'd like one more rewrite. So before I go ahead and find the derivative, because we need the f prime of x, f prime of c, we're going to write f of x as 1 over natural log 2, and then in parentheses, x times natural log x. And that's getting pretty crowded, so I'll rewrite it. F of x is equal to 1 over natural log 2, and that's a constant factor that I'm taking out, so it's just going along for the ride. X times natural log x. So next I'm going to find the derivative by using the product rule. So we have f prime of x is equal to 1 over natural log 2. And now the product rule. We have our first and our second factor. So first is x times the derivative of the second factor. The derivative of natural log of x is 1 over x, plus the second factor, natural log x, times the derivative of the first factor, which is 1. So that's the product rule in the brackets. So f prime of x, cleaning it up a little, 1 over natural log 2 times 1 plus natural log x. So that's our f prime of x. We want f prime of c, and we know what that notation means. It means where x was, you put a c instead. So f prime of c is equal to 1 over natural log 2 times 1 plus natural log c. We put a c where x was. And all of this goes here. Oops, that was an ugly arrow, but you get it. And then remember, the 2 is what we computed for going there, and we set them equal to each other. I hope I'm not going to run out of room. Let's see how we do. So now I have the whole thing put together. 1 over natural log 2 times 1 plus natural log c is 2. And I'll go ahead and multiply by natural log 2 on both sides. And that gives me 1 plus natural log c equals 2 natural log 2. And next I'll subtract 1. So we get natural log c equals 2 natural log 2 minus 1. And before we move over, this 2 natural log 2, we can make it into an exponent when you have logarithms. Remember, exponents can come forward as factors, and you can put them back again too, so they can go back as exponents. So that will give us natural log c equals natural log of 2 squared minus 1. And now we're going to raise each side to the, have it to the base e. So we're going to apply e to both sides. E raised to the natural log c, that'll get our c solved for, and that's our goal, is equal to e raised to the natural log 4, 2 squared, and then minus 1. And you can't subtract 4 minus 1 because the 4 is locked up with the natural log. So c is equal to that. That is a wonderful answer. Your book goes a little bit further, and I'm happy to show you what they're doing, but it's really not something you need to know quite yet. We will be using this in chapter 6, actually, so it's good to see it, I suppose. So I'll write or. That answer's fine, or this answer. If we write this as c equals e raised to the natural log 4 times e raised to the negative 1 power, which feels really weird. But if we wanted to go from here to here, we would add the exponents. And so you would have e to the natural log 4 plus negative 1, which is e to the natural log 4 minus 1, and you would get right back there again. So it's legal. And then I keep going. C is equal to e raised to the natural log 4 and times 1 over e to the positive 1. Or c is equal to e raised to the natural log 4 over e to the 1. And at some point in here, we need to realize that e raised to natural log 4, these are inverse operations, so they undo each other. And so it's just 4 over e. 4 is a number, e is a number. It's just less than 3, 2.71-ish. So you're looking at roughly 4/3. Okay, so your answer over here, just fine. But you're going to see stuff like this with simplifying in the book, so it's nice to be aware of it. Have a great day. Let me know if you have any other questions.